Okay, so the last thing to finish up our multiplication is just to write the general rule. I already have all the steps written out here for you. It's basically just FOILing. Or if you use the box method, that's fine. Basically, what you're doing is you are combining the real terms and combining the imaginary terms. That's the gist of this problem. So if you don't understand all of the letters, that's fine. Just go ahead and jot it down in your notes so you have access to it so you can see it. But we're basically just FOILing or using the box method to combine these terms. So that finishes up multiplication. So we're going to move on to the last concept, which is complex conjugates. So let's turn to the next page. So here on page 129, we're going to look at what's called complex conjugates. So complex conjugates are just kind of opposite imaginary terms. So it's a special term that we use only talking about complex numbers. So basically, the complex conjugates are where the imaginary term is opposite. So right here, if we have 2 plus 3i, its complex conjugate is 2 minus 3i. Notice the only thing that changed was the imaginary term. The 2, or the real number, stayed the same. So real stays the same, imaginary flips, or it's the opposite. So just quickly going down these two problems, 2 minus 9i, well, its complex conjugate would be 2 plus 9i. Again, just the imaginary term gets changed. Notice how the 2 stays the same. So I want you to try part B, just to write the complex conjugate. Okay, so the complex conjugate in part B, the negative 5 stays the same. The only thing that changed is the imaginary term. So instead of being a positive 2i, it now became a negative 2i. So something cool happens when we multiply these complex conjugates together. So let me show you that in part A, and then you're going to do part B. So again, you can use FOIL or box method when you're multiplying. I'm going to just FOIL. So we have 2 times 2, so 4. Then we'll do 2 times the 9i, so positive 18i. So inner is this negative 9i times 2, so that's a negative 18i. And then last, negative 9i, positive 9i would be a negative 81i squared. Notice these two middle terms, the i's, negative 18, positive 18, cancel. So right now we're left with 4 minus 81i squared. That is not our final answer. If your final answer has an I squared, you are not done with the problem because we know that I squared is negative 1. So right here, this is a negative 81 times a negative 1. Negative 81 times a negative 1, or negative times a negative, is a positive. So really, we have 4 plus 81. Well, 4 plus 81 is 85. So whenever you're multiplying complex conjugates, you will always get a real number. That's a special relationship with complex conjugates. When you multiply complex conjugates, the i's go away. Your final answer should just be a real number. No i's, or I squared. So now seeing that, I want you to multiply in part B. Your final answer should be a real number. Okay, so in part B, when you FOILed or used the box method, you got these different terms. Notice that you have a positive 10i, negative 10i. Those two terms cancel. We also have an I squared. So I squared equals negative 1. So because I squared equals negative 1, right here we have negative 2 times a negative 1. Well, this negative times a negative means this is just a positive 2. So we still have that 25 out in front. Now it's plus 2. Wait, sorry, I made a mistake here. That should be a negative 4. Sorry, so this is negative 4i squared. Okay, so I squared still equals negative 1, so negative 4 times negative 1 is a positive 4. So let's make that right over here. So it's 25 plus 4, my apologies. So this is 29. So always check your math. So that's your final. Notice it is a real number with no imaginary terms. So let's just write the general rule for complex conjugates when you're multiplying. So basically what happened is the two middle terms, those I terms, canceled out. So we kind of just squared the first term and squared the last term is what we ended up just doing. So it just ends up being, our general rule is a squared plus b squared. So a raised to the power of 2 plus b raised to that power of 2. So that concludes our notes. Next, you will move into Delta Math and do practicing with add, subtract, and multiply complex numbers. Let me know if you have any questions.